each coordinate is a property, okay? And I have the properties here. Here's Kentucky. It is worth, let's see, to spend it on, way down here. On Kentucky.
It's by your fingers.
Okay, $220. Everybody on the y-axis go up to 220, approximately.
Oh, they don't know.
Okay. Now, if I count how far Kentucky is from go, okay, Caden, start at go, which is there. Count.
I have to pass it.
Okay, I'll make this easy on you. 10, 20, 21. Because you count my tens. It's all right, you didn't know that. There are 10 spaces on each row. So it's at 21. Okay, go over to 21 on the x-axis. So 220 and 21. Would that be right about here?
Yeah.
Does that answer your question? Okay, that's Kentucky Avenue. At least one of those that's really close to the average is Kentucky Avenue. Now, the one that's on the other side of the average should probably be the property that is just before that, right?
Which would be.
Which is New York Avenue, which is worth $200 and is 19 spaces from go, okay? Does everybody understand how the points are plotted now? If you just count distance from go and look at the property value, that creates those two values. And then you have a scatter plot, which I was talking to Annie, she thought it was strong, or fairly strong, okay? Does everybody agree that's a strong correlation?
Yeah.
I think so too. How strong? I don't know. Let's take a guess.
Strong.
Since we all kind of feel that way, at least I hope you do. Does anybody think it is a 1, 2, 3, 4, 5, 6?
6 is the yellow one.
Okay, 6 is here. 6 is still moderate. Now 7, you're getting into the strong range. Everybody gonna guess 7? That's totally fine. Yep. 1, 2.
It's 7.5.
Okay, so let's stay with 7. 1, 2, 3. All right. How many people are gonna go 8? Most of us. 1, 2, 3, 4, 5, 6, 7, 8. Is anybody going 9? You go yet?
I
10's perfect. 10's perfect.
It can't be a 10. 10.
What?
10's perfect.
Lando, you wanna go 9?
9.
Good, okay. 2 for 9. But yeah, that's, if we're playing Kahoot, this is where the numbers would fall, right? We'd have a range and say we're somewhere in here.
10's like
Identify these 2 points on the graph now. So let's do the work. Identify 40, 340. So go over to 40, which is at the end of the x-axis here. Go up to approximately where 340 would be, which would be on the red line. Of course it is, because that's what we're doing, right? So circle that point. Oh, you don't see that. Right there.
Oh, I don't see that.
That's 40, 340. Okay. The other coordinate is at 10, which is there, comma 135, which would be approximately on the red line. Okay. And anytime you do this, notice, do these 2 points have to be blue coordinates?
No.
No, they're just 2 points that you pick on the line. That's all I do. I just scan the line in Desmos and I say, here's a coordinate approximately, here's a coordinate, let's find the slope. Okay. All right, do the work. Try to stay ahead of me right here because I think you should be able to. I'm going to start with the slope formula. y1 minus y2 over x1 minus x2.
Jeez.
So it doesn't matter which y I start with. Okay. Do you want to start with 340 or the 135?
340.
Sounds good to me. We're going to call that y1 and y2. So 340 minus 135. Okay, Luke, this is important now though. Since you started with 340, which x do you have to begin with down here?
40.
Good, you have to be consistent, okay? So that's 40 minus 10 on the denominator. Numerator, based on my eyes, that looks like
305.
205. I think it's 205.
Oh, there's a 1.
Yep. And then 40 minus 10 is 30. I'm gonna do 2 things here. I'm gonna simplify the fraction because I can. So if you divide both those by 5, that would be 41 over 6. Let's analyze that slope for a second though. Do you know what that means? Wait, I told you what the x-axis is, right? It's the distance from go. And then the y-axis is property value. So if this is y or x minus x, every 6 spaces you move on the board, 1, 2, 3, 4, 5, 6, costs you $41 in property value, okay? Or raises it $41. So if you use 6 more spaces, it's another 41 bucks on average, okay? That's what that like slope kind of tells you. In Desmos, we're not gonna get a fraction, we're gonna get a decimal. So I'm gonna go ahead and divide those, just so I can compare easily. 6.83, 3 repeats. Hey, everybody do this. Make sure you put the bar just over the 3, because that's what the calculator shows, just the 3 repeats. Draw a line. If you have some space, I hope you do, or find some space. And this is what I need you to get comfortable with, okay? Finding the y-intercept when you don't know where it is. Well, we kind of do. Look at this. Everybody circle the y-intercept right here. And in the next 10 seconds, write down where you think that is number-wise on the y-axis. Go, 10 seconds. Take a guess. Time. Okay. Did your eyes deceive you? Did you know what you're counting by in terms of increments? Okay. This right here, folks, is 100. Label that 100. Okay. Can we all agree it's over 50?
Yes.
Over 60?
Yeah.
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 Over 70?
Yeah.
Yeah.
I guess it was 60.
I guess it was
Okay.
65.
I thought it was
60, 65, maybe 70. Anybody go higher than 70?
I'm thinking like 73.
Okay. 73? 78. So our range is between 60 and 80. How's that? Okay. When we find the y-intercept, it better be between 60 and 80 because that's what our eyes are telling us. All right. Y equals mx plus b is how we begin this process. Okay. Then you plug in for what you know. I know what the slope is. I just calculated it to be 41 over 6. So m is going to be 41 over 6. The x and y that you see in the formula, just grab an x, y that you know is on the line. Well, we have 2 of them right here. We got 40, 340, you could use that. Or you could do 10, comma 135. I choose this one, everybody circle that one. We're gonna bring those x, y combos over into our formula and just drop them in their places. So in place of x, you're going to put 10, because that's what the x value is. And in place of y, you're gonna put 135. You don't know this process, it looks incredibly difficult, but if you just like follow this, do you know what a y is? Drop it in its place. Do you know the slope? You found it, okay? That's not that difficult to understand, that you're just replacing numbers in place of variables. We don't know this one yet, do we? We guess between 60 and 80, okay? So plus b, now we gotta do the work to find it. 2 steps, multiply these together, okay? Wait, if that's times 10, isn't that just like 410 over 6? You see that? Or could we do some cross canceling? That's last year, okay? Yes, you could do that. And I'm more concerned about the process, so could you just do this too? Yeah, do that, okay, I don't care. 410 over 6, if you divide those, is 68.3 repeating, which is 68 and a third. That seems more reasonable. Let's go 68 and a third. Plus b equals 135. Placement is king right here. You need to place these things in their spots. You did this, this is here. There's your equal sign. There's your 135. Line everything up. What are you gonna do with this number?
Subtract 68 and 1 third.
Thank you. Subtract it from both sides. Okay. So minus 68 and a third from itself, it cancels. See you later. Subtract 68 and a third from 135, and we have what we think the y-intercept is. Okay. 135 minus 60. I can't type numbers. Trying. Okay, I'm gonna start this right now. I'll get there. 66 and 2/3. Okay, our eyes did not deceive us, that's what we thought. As a group, we thought it was somewhere in that range.
I said 65.
Nice. Okay, here's what we're gonna do. I say we write those 2 values down that we just found, okay? And put them on the line here. So the slope that we found was 6.83. Let's go ahead and record it as a decimal because that's what we're gonna get. The y-intercept we found is 66.7. How's that? Because it's 2/3 and it rounds to the 7. All right, let's see how we did. They got a slope at 6.78. We got 6.83. Close?
Yeah,
Close.
we they read
Their y-intercept is 67.2. What's ours?
60, 66.
6.7. Close?
Yeah,
You know why it's not exactly the same?
because
Because of
Error.
this guy. So when I found these coordinates, here's what I did, I'll show you again. I just kinda like slid up and down this line like this. And when I got to 10, I tried to approximate, see that? Isn't it about 135?
yeah,
But is it exactly 135?
no.
No. So when you cut off 0.127, that's rounding, you're gonna lose some value, okay? And I did the same thing when I got to 40. I said it's about 300 and, what'd I say? I said 340. Okay, I'm off. I should've gone 338, dang, that's, you know what, I could've made that better. That's my fault. I could've made that a lot better. Okay, R squared value, does anybody see it?
Yeah.
Reported 0.771. Yeah, so, strong. Right in the middle of the strong range. Okay. Let's go back in time. Did anybody wonder what's going on here, here, and here? Maybe there?
I think those were the
Those are probably the railroads.
utilities and railroads.
Okay, so B&O Railroad is $200, okay? And then you've got Short Line, which is also 200, and Reading Railroad in Pennsylvania. They're all 200 bucks. But that is not predicated on where they're on the board. So notice if you start at go, that's $200 in the first row. This is $200, this is $200. So the distance from go does not create the value of those properties, right, or the railroads. That's why they kind of are like standing out as almost like outliers, right? They're not following the trend. This one's way over here, all by itself. And so is that one.
Which
Wait,
one's?
what's this one?
Utility.
That's right.
I know my monopoly.
You do, it's Waterworks, okay? So Waterworks is way over here, but it's only 150 bucks, surrounded by properties of 260 and 280, okay? Marvin Gardens and Venture Avenue are way more than this. But they just kind of put that in there as if you land on it, you have to pay utilities. So if you don't know how monopoly works, okay? You travel around the board, you land, you buy property. If you land on somebody else's property, you have to pay them rent, okay? That's how you acquire more money. Now, Boardwalk and Park Place, you guys see those on the graph?
Yeah.
They're over here.
Yeah.
Those are the two most expensive properties. They're worth $350 and $400 respectively. Boardwalk's 400, Park Place, sorry, this is crossed out, is 350. And they are the furthest from go. Actually, they're the closest too, because look, see how they're like right next to go?
Yeah.
But you have to travel, you can't go backwards, you have to travel around the board to get to it. Okay.
You guys renamed the Eiffel Tower.
So what some kids did is they adopted this game for a different game. They like made their own game out of it because they were in my algebra class, and that's what we were doing that time. So just ignore that.
Wait, you taught algebra?
I do currently teach algebra.
Yeah,
Yeah.
that's the
I
advanced
was,
class. It's
I don't know
Algebra 1.
why I thought that was like an ELA thing.
There you go. I
Yeah.
literally
I thought
wrote
it
the
was like-
book.
I thought it was like a grammar thing or something.
What?
I just brain fart. I was like, wait, what?
We'll talk about that later. Okay, last thing to wrap this up. I got all my properties here, don't really need them. Do you believe there is a correlation? Look, I got the word believe on my shirt. Do you believe there's one? Well, here's what you have to do. Take the belief out of it. If it's strong, say yes, okay? Like, mathematically, there is a correlation because there's a connection between the distance you travel and the cost of the properties. There's some outliers, the railroads, right? The utilities, that's fine. Okay. So I'm gonna say yes to correlation. How about causation?
Yeah, no. Which do more money, the railroad or the boardwalk?
Boardwalk is 400, Park Place is 350.
How much do you, like, if you land on, how much do you get paid?
Oh yeah, it's like rent.
Yeah.
If you land on Boardwalk, it depends on how many houses you build on that as well. So you could end up paying $2,000 in rent if you have a hotel on there.
I thought hotels costed more.
Okay, I'm gonna go to the hotel and they're like, it's
For
for
Graham,
boardwalk.
he owned both Park Place and Boardwalk, but hotels on both.
Hey, last thing, write this word for me, causation. Do you guys remember the one from Wednesday, the cow and the gas prices?
Oh, yeah.
It's like, is the gas prices going up causing this? You're like, not really, but there's an influence there. There's like, there's a something, but it's not direct one-to-one. This one is almost literally one-to-one causation. Like, you move on the board, it's higher property. excluding what, like 5 properties, right? So I'm gonna say, yeah. The way that you move is causing the properties to increase, so therefore correlation, yes, causation, yes. Why isn't this correlation very strong? Because of the railroads. You take the railroads out of there, you've got something in the 95% range easy, okay? Because look how tight that window is. There's, almost every point is touching the line, except for those 5. All right, cool.